should take it slow.
Hello everyone, today we're doing integration by parts, which can be quite useful for integrating products. Alright, so first of all, let's recall the product rule of differentiation. So if we have d dx of u v, that would be equal to u dv dx plus v du dx. Now, if we were to integrate both sides with respect to x, we end up with uv equivalent to the integral of u dv dx plus the integral of v du dx. So this is, and then we are going to transpose and we're going to get integral of u dv dx equivalent to uv minus the integral of v du dx. So in integration by parts, this is the formula that we'll be using. This is the formula we're using for integration by parts. Now, let's just show you an example to show exactly how this formula is used. Let's say we must integrate x times e to the x dx. Say we're integrating. Well, let me draw this symbol a bit better. Okay, so let's say I'm going to integrate x e to the x dx. Now, what we will do from here, we have our formula. So we're going to assign one of these as u and the other one as dv dx. In this case, it's best to assign u equals x and dv dx equals e to the x. Now, let's move on to further. So now what we need to solve for, we need to solve for v, and we need to get du dx in order to carry out this integral fully. So firstly, in order to get v, we're going to have to integrate this. As we know, the differential of e to the x is e to the x. Therefore, if we integrate e to the x, we'll get back e to the x. So from there we know that if dv dx equals e to the x, then v is equal to e to the x. So we know v, and now what we need du dx. Now see, it was a good thing we did this assigning, because now we get du dx to be 1. when we differentiate u with respect to x, we get du dx to be equivalent to 1. So now what happened is that we can rewrite our previous integral as the integral of x e to the x is equivalent to uv, and u is x, v e to the x. So we have x e to the x plus, sorry, minus the integral of v du dx. V e to the x and du dx is 1. So minus the integral of e to the x dx, which, as we said before, is just e to the x. So now we can simplify this further, and we just have x e to the x minus e to the x. See, so it's quite simple, and we could just factorize that out. So this is how you do integration by parts. If you just follow the formula, and you just can't go wrong. Assign a value to u and assign one to be dv dx. Now you have to be very careful about which one you assign as which. Let us do another example. This time we'll integrate x sine x dx. Alright, so using the formula that we used before, firstly we're going to assign u equal to x, which again comes in handy because when you derive u, you just set 1. And then so we're going to assign dv dx as sin x. Now what happens, we're going to solve for v and we're going to solve for du dx. So let's just set that equal to solving for v. So now we're going to integrate this. If we integrate sin x, we get negative cos x. Integrating sin x, we get negative cos x. So therefore v is equal to negative cos x. If we differentiate u, we get 1, therefore du dx is just 1. So we're going to have uv, so negative x cos x minus the integral of v du dx. V is sin x and du dx is 1. So we can have the minus the integral of sin x dx wait, no, my apologies, minus the integral of negative cos x, because remember that v is equal to cos x and du dx equal 1, so it's actually the integral of negative cos x dx. And of course, integrating that, we'll get negative sine x, and minus minus gives you a plus. So we'll end up with negative x cos x plus sine x. And when you're integrating, always remember to add the plus c if it's indefinite integration. And that's how you integrate by parts. It's basically a product rule for integration. Thanks for watching. See you next time.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.